friends, welcome to our channel. Here we are going to look at problem 2845, Count of Interesting Subarrays. This is a daily challenge problem, but the purpose in this video is to demonstrate how to reduce this problem into a plain type problem, and then we solve the plain type problem. So here, basically, we want to find the number of interesting subarrays. So, and subarray is interesting means among the indices which corresponds to numbers that modulo this given constant equals k, right? We also need the count modulo this constant also equals to k. If this condition is holds, then we say such array a interesting subarray. So if you look at the two examples here, it gives a detailed explanation, especially example 1. So here the length can be as long as 10 to the power 5. In other words, we need to think of time complexity. Another one is that the modulo is greater than or equal to 1, that is positive, and the k is less than modulo and greater than or equal to 0, right? So this will be the main problem statement. So here actually, if we look at the definition, and we want to find the indices such that this indices modulo this modulo constant equals the k, right? So we can first check, let's say, int, so y modulo this modulo constant equals k for y in nums, right? So we can print out this flags. So this will tells us the corresponding positions which corresponds to elements that such that this condition holds, right? Then in order to satisfy this condition, we just need to consider the sum of the subarray, because if we translate this into a flag sequence, right, like this one, then the sum of the subarray in flags will correspond to the count here, right? Then we just need to know, make sure the sum satisfy this condition. So this will be a very plain problem, right? We have practiced quite a lot, so we can solve it using dict and check, right? If you look at my previous videos, so we have channels which contains lots of problems that can be solved either by dict and check or set and check. So actually the two sum problem in leetcode is a typical set and check problem, right? So if you are not familiar with the reduced problem, you can do this problem or these problems. Find the number of subarrays such that the sum equals a given target. Or you find the number of subarrays such that the sum modulo some given constant equals a remainder, right? So this will be similar, right? So now let's look at the current coding. The current coding will be a dictionary and check. Actually here also we do some count. So first we are going to initialize a result variable. So this result variable is a counting variable. We are going to return its final state. And we need a dictionary. So here the dictionary stores the remainder and the frequency. Here the remainder means the sum, the running sum. So modulo this modulo constant. So you'll see the code, you will understand the logic, right? So for y in flags, notice that the element in y is either 0 or 1, right? So the current will increment by y. So the current will be the sum from very beginning up to now, right? So first I'm going to do a division. So dev mode, so current, so modulo, right? First, if r is greater than or equal to k, meaning that for the current sum, if I write, say, let me add an index. So I will not use it, but I will make it just print out something, or it's easy for us to expose user ideas. So the current will be the sum from the very beginning up to the current index I, right? So if r is greater than or equal to k, so we want to seek remainders, that is r minus k. So if this remainder appears before and it has a frequency, then the current sum minus that sum corresponding to those remainders will give subarrays corresponding to the remainder will be r minus key. That is the key, right? Therefore, for the count will be d get this remainder. So if not appeared yet, so we're going to set it to be 0. So this is the one case. Another case is if r is less than k, we cannot consider r minus k because it's less than 0. But if q is greater than 0, we can borrow a modulo, right? So we seek modulo plus r minus k in the previous state. So therefore, the result will be incremented by modulo plus r minus k. If this does not a dictionary key, so we set the frequency to be 0, right? So then no matter what, we're going to update the dictionary state by this d get. So if it appears before we get that one and increment by 1, otherwise the default will be 0. So this will be the full code. So let me first run it. Local variable current. Let's see. Let me define that. Yeah, it passes the two cases. So now let's look at the generic case. Yeah, it passes all the cases. So if you want to better understand it, so you can do some print. For example, you can print I, current state, and the number, and the dictionary state, and also the result when enter, right? So you can also print out this after exit, right? After enter I and exit this I. So let me also print out some empty space. So now you can see for this one it should be 3, right? So you get right 1, 2, and 3. And for this you should get 2. Let's see. Yeah, you get a 2, right? So from this print, you can actually give a detailed walkthrough of this code by yourself. I guess certain level of abstract thinking is crucial for doing such coding problems. Actually, if you practice more, once you see this problem, you should be able to quickly identify the pattern and write the code. So actually, in the previous video, I guess I also did something like this, but I didn't do this check. So with the current test cases, without this check, it will be do the job. However, adding this if makes things more rigorous. So with that said, I guess that's the coding part. A last comment is that we have a big channel in YouTube, which contains many playlists, so including say dictionary and check and set and check. So you are welcome to check out problems there and do some practice. Hopefully you will get something useful. Thank you for watching.